If you missed number 1, this is an explanation of how to solve it correctly. So we have an equation here. It's going to be multi-step, and we want to solve for x. But x is on the top of this fraction, and we can't do anything with that numerator until we eliminate the denominator of -5. So what we'll do is eliminate that -5 by doing the inverse of division by -5. So that would be multiplying by -5 on both sides. Okay, so divide by -5 and multiply by -5 are inverses, so they cancel out. And then we simplify. -5 times -5 is positive 25. And then we bring down the numerator. Okay, now again, we want to remember we're getting x by itself, so we need to move the -4. So we add 4 to both sides and simplify. 25 plus 4 is 29 equals x. If you missed number 2, here's an explanation of how to solve it. The goal is to solve for p, but we have 2 p's, so we want to make sure that we end up with just one variable of p. So we don't have any parentheses to eliminate. We'd move to the next step, which is combining like terms. So remember, we have a left side of the equation and a right side. On the left, we just have 5, but on the right, we have some like terms. We have 9p and -8p. So we can simplify that by combining them. 9 minus 8 is 1p. Bring down the plus 10. Now we want to get the variable on one side and get the constants on the other side. So the variable p is already on one side of the equation. We don't have any more p's, so the next step would be to move the constant term to the other side by subtracting it on both sides. So 5 minus 10 is -5 equals p. Here's an explanation of how to do number 3. First, we need to eliminate parentheses. So we'll take the number in front of the parentheses and distribute it or multiply it by each term in the parentheses. So 2 times 4x is 8x. 2 times -2 is -4. Bring down the equal sign. On the other side of the equation, we have to distribute again to eliminate the parentheses. So we'll multiply -2 times -x and get a positive 2x. -2 times positive 8 is -16. Now we want to see if we can combine like terms. Remember, we have a left and a right side of the equation. On the left, we have 8x and -4. They aren't like terms. And on the right, we have 2x and -16, and they are not like terms. So we can move on to the next step, which is to move the variables to the same side. So notice I have a 2x and an 8x. So I'm going to move the 2x by using inverse operations. On the left, we simplify. 8x minus 2x is 6x. Bring down the -4. Equal sign, and bring down the -16. Now we want the constants, or the plain numbers, on the same side of the equation. Our x is here on the left side of the equal sign, so we want to move the -4 away from it. The inverse of -4 is +4. And we simplify. 6x equals Negative 16 plus 4 is negative 12. And finally, we can split the 6 away from the x by division. 6 divided by 6 is 1, so we get x, or 1x, equals negative 12 divided by 6 is negative 2. Number 4 is a literal equation, and that's the first thing that we have to do here, is write the literal equation to show the relationship. So energy, E, is equal to, so E equals mass, which is M, times, tells us to multiply, the speed of light squared. The speed of light, we're told, is c, and squared means to give it an exponent of 2. Next, we solve for m. So to solve for m means to get m by itself. So m is being multiplied by c squared. So we need to get rid of the c squared. The opposite of multiplication is division. So we'll divide by c squared on both sides. That leaves us with E divided by c squared equals m. Number 5, the total number of cups of flour, F. So let's make a note there. Cups of flour is F. So the total number of cups of flour, F, that Julie has left after baking C number of cupcakes, so C represents the number of cupcakes, is given by the equation F, or the cups of flour that she has left, equals negative 2C plus 100. If she has 28 cups of flour left, let's stop right there. Our equation is F equals negative 2C plus 100. Then we're told that she has 28 cups of flour left. Cups of flour is F. So 28 is F. Now we want to know how many cupcakes did she bake. So we need to know what is C. So to solve for C, this is a two-step equation. We need to move the constant terms to one side. I'll remind you we don't have parentheses and we can't combine like terms at this point. So to solve for C, we need to move the constant to the opposite side of where the C is located. So we need to move the positive 100 to the other side. 28 minus 100 is a negative 72. Bring down the equals, and the negative 2C. Finally, we can split the negative 2 from the C by using the inverse of multiplication, which is division. Negative 2 divided by 2 is 1, and now we just simplify. Negative 72 divided by negative 2 is a positive 36 equals C. So she has 36 cupcakes. For number 6, we want to write an equation and then solve for x. The length of one side of a triangle is 14 inches. Okay, let's draw a triangle. The length of one side is 14. The second side is x plus 7. The third side is 2x minus 1. And the perimeter, or the sum of all sides, is 50 inches. What is the value of x? So if the sum of all the sides, that means we need to add 14 plus x plus 7 plus 2x minus 1. And that total sum is 50. I put these in parentheses so you can see that these are the three individual sides and we are adding them together. Since we don't have anything to distribute, we don't need those parentheses. Now we can combine like terms. On the left, let's see what we have. We have a 14, positive 7, minus 1. Then we have a positive x and a positive 2x. So we want to combine as much of this as possible. We can combine the two x's. We have x plus 2x, which is 3x. And then we have 14 plus 7, which is 21, minus 1, which is 20. And that all equals 50. Up next, we want to move the constant terms to the same side. So subtract 20 on both sides to move it away from the x. That leaves us with 3x equals 30. Finally, we need to split the 3 away from the x using inverse operations. So x equals 10. Here's an explanation of how to complete number 7. Dave worked the following problem. Solve 6 times x plus 5 minus 2 equals 20. His work is shown below. We want to know where an error occurred. In step 1, let's see what he did. In step 1, we would have to distribute 6 times x and 6 times positive 5. So if we did that ourselves, we would get 6 times x is 6x, 6 times 5 is 30, bring down the negative 2 equals negative 20. That doesn't look like what Dave got. Dave forgot to distribute. He didn't multiply 6 times 5. So his error occurred in step 1. Here's an explanation of how to do number 8. Write an equation and solve. 5 more than 3 times a number is 29. 5 more than. That typically means that we have something and then we're going to add 5 to it. So let's leave a space for where our something is and then let's add 5 to it. That's what 5 more than means. 3 times a number is what comes before it. That's our something plus 5. So 3 times a number plus 5 is 29. We can write 3 times a number by just 3 times x, or you could use 3 times n or any other variable. Is tells us equals to 29. Now we want to solve. Let's rewrite this so it looks a little nicer. 3x plus 5 equals 29. So 3 times what number plus 5 gives us 29? Well, we want to get our constants on the same side, so we'll subtract 5 on both sides to get it away from the x. So 3x equals 24. 3 times what number gives us 24? We can isolate the x by splitting the 3 away from it through division. So x equals 8. Here's an explanation of how to complete number 9. Write an equation and solve. 9 less than a number divided by 3 is 4. 9 less than tells us that we have something, and then we subtract 9 from it. So let's leave a space for 9 less than. Nine less than what? Well, we have something and we're going to subtract 9 from it. But that something is a number divided by 3. So for that number that we don't know, we'll call it x, and it's being divided by 3. All of that is equal to, or is, 4. Let's rewrite this so it looks a little bit nicer. X divided by 3 minus 9 equals 4. So notice this is 9 less than a number divided by 3. Notice in this one that we have our x is part of a fraction, but we have a completely separate term that we can move first. So the inverse of minus 9 is plus 9. So we have x divided by 3 equals 4 plus 9 is 13. Finally, we can do the inverse of division by 3, which is multiplication by 3. So we'll do times 3 on both sides. Times 3 and divide by 3 cancel out, and we're left with just x equals 13 times 3 is 39. Number 10 is a literal equation, and we want to solve for f. F is inside this set of parentheses, so we need to undo that set of parentheses by getting rid of what is in front of it. To get rid of this 5 divided by 9, we can do what's called multiplying by the reciprocal. The reciprocal is the flipped version of that fraction. I'll show you why we do this in just a second. Let's rewrite our equation, give ourselves a little bit of space to multiply by 9 over 5 on both sides. So if the goal is to get rid of the 5 over 9, we multiply by the reciprocal on both sides. The reason we do that is because now this fraction is 9 times 5 divided by 5 times 9. Well, what that gives us, 9 times 5 is 45, and 5 times 9 is 45, and 45 over 45 is just 1. So all of that cancels out. On the left, what we have is 9/5 c equals, and on the right we have f minus 32. Now our goal is to get the f by itself by moving that negative 32. So we will add 32 to both sides. Now notice that 9/5 c has the variable c, and plus 32 is just a constant. So when we rewrite this, it will look like 9/5 c plus 32 equals f. Let's look at number 11. There are 3 parts to number 11. We have 2 functions. We have f of x which is x squared plus 5, and we have g of x, which is 4x minus 1. These are 2 different functions. They have different names. And our task is to evaluate 3 different numbers for those functions. The first one we'll do is f of negative 1. So f of negative 1 means that we're going to take negative 1 and plug it in everywhere we see an x in f of x. So if f of x is x squared plus 5, then whatever's in the parentheses is what replaces the x. And then we just simplify. Negative 1 squared is negative 1 times negative 1, which is a positive 1, and bring down the plus 5. 1 plus 5 is 6, so f of negative 1 equals 6. G of negative 1 means that we're now going to plug in negative 1 for x in the function g of x. So if g of x is 4 times x minus 1, then g of negative 1 just means we're going to plug in negative 1 for x. Now we simplify. 4 times negative 1 is negative 4. Bring down the minus 1. Negative 4 minus 1 is negative 5. So g of negative 1 is negative 5. Finally, we want to find f of 5. If f of x is x squared plus 5, wherever we see an x, we are now going to plug in a 5. And now we simplify. 5 squared means 5 times 5, which is 25. Bring down the plus 5 and continue to simplify. 25 plus 5 is 30. So f of 5 equals 30. Number 12. Given the function f of x equals negative 6x plus k, find the value of k if f of 1 equals 4. This uses the basic understanding of function notation. Your goal is just a little bit different. So our goal is now to find the value of k. So what is k if f of 1 is 4? So if f of 1 equals negative 6 times 1 plus k, and we know that f of 1 is equal to 4, then what we're using is this equation to solve for k. So we know that if we plug in 1, we get out 4. So now let's solve for k. Negative 6 times 1 is negative 6, plus k equals 4. And finally, we just want to isolate k by moving that negative 6 using inverse operations. So k equals 10. Number 13 is domain and range. State the domain. Remember that the domain is always the x values. And the range is the set of y values. So the x values are 5, 1, 2, -1, and 8. That's because any point is always written as x, comma, y. So let's see which option can we eliminate and which options can we keep from the choices below. 5, 1, 2, -1, 8 are only found in option B and option D. So we can eliminate A and C altogether. Now we need to determine which is the correct range. The range is -2, -2, 3, 2, 0. So between B and D, -2, -2, 3, 2, 0 is only found in B. Number 14. What is the solution of the inequality? Remember that inequalities are solved the same way that regular equations are solved, but if you multiply or divide by a negative, you have to flip that sign around. Our goal is still to isolate the x, so let's rewrite this and give ourselves some more space to work this out. We can't eliminate any parentheses, and we can't combine any like terms, but we can start to isolate the x by moving the constants to the same side. That means we want to get the plain numbers both away from the x. So we have a 1 that we can subtract on both sides to move it away from the x. So negative 5x is less than or equal to negative 20. Now we need to isolate x by dividing by negative 5. But notice since we are dividing by negative 5, if we divide by a negative, we have to flip the inequality. So immediately, I'm going to write that down first so I don't forget. Now we can simplify. Negative 5 divided by negative 5 is just a 1, so that's 1x, or x is greater than or equal to negative 20 divided by negative 5 is a positive 4. So x is greater than or equal to 4. Number 15, what is the solution set for this inequality? Well, to solve this inequality, we want to get the variables on the same side. So we can subtract 6x on both sides. You could subtract 2x on both sides. So 2 minus 6x is negative 4x. Bring down the plus 1 is less than or equal to 9. Then we want to move the constants to the same side. So we'll subtract 1 on both sides. Negative 4x is less than or equal to 8. Now we need to split the negative 4 from the 8. But notice when we do that and divide by negative 4, since we're dividing by a negative, we have to flip the inequality. So I'm going to write that down first so I don't forget. Now we simplify. Negative 4 over negative 4 is 1. X is greater than or equal to, and then 8 divided by negative 4 is negative 2. So the solution set is that x is any number greater than or equal to negative 2. So does this mapping below represent a function? If something is a function, that means that there is one output for each input. In other words, you can't have two repeating x values. Or it needs to pass the vertical line test. So in this mapping, we have the x value of negative 1 gives us 2 as a y value. 0 gives us 2 as a y value. So far, we don't have any repeating x's. 1 gives us 3, 2 gives us negative 2, 8 gives us 3. So since we don't have any repeating x values, it is a function. Number 17, Susie is buying In-N-Out burgers for lunch for her friends. The hamburgers cost $3.50 each, and the drinks cost $1.50 each. She wants to spend no more than $30. What inequality represents the number of hamburgers, H, and the number of drinks, D, that she can buy? So first we need to recognize that this is an inequality, and she wants to spend no more than $30. That means she can spend $30, but nothing higher than that, only something lower than that. So this is going to be a less than or equal to inequality. So total amount spent needs to be less than or equal to $30. Okay, if hamburgers cost $3.50 each and drinks cost $1.50 each, we need to set up that $3.50 per hamburger, so $3.50 times however many hamburgers she gets, plus $1.50 times however many drinks she gets. That total, meaning that we're adding them together, has to be less than or equal to $30. So the only inequality with less than or equal to and the correct location of $3.50 per hamburger and $1.50 per drink is option A. Notice that option C is close, but it has the incorrect location of the variables.